Now we're going to take up one more problem on simply supported beam. Problem number 34. It reads as, draw the SFD and BMD for a simply supported beam capital ABCD of span 5 meters such that AB equals 2 meters, BC equals 1 meter, BC equals 1 meter and CD equals 2 meters. It is loaded with UDL a 5 kN per meter over AB and UDL of 2 kN per meter over CD, and also carries a point load of 10 kN at 2.5 meters from the left support. So this is the problem which is given. So we need to find out the support reactions first. That is at the point A and D as it is simply supported. So we have the support reactions at RAV and also RDV at the points A and D. Now to find out the support reactions, so taking the moments about the point A, RDV into 5 meters will be equal to 5 into 2 into 2 by 2 plus 10 into 2.5 plus 2 into 2 into 2 into 2 by 2 plus here 5 minus 2 which is equal to 3. So 2 by 2 plus 3. On simplification you will going to get it as 51. So therefore RDV will be equal to 51 divided by 5 will be equal to 10.2 kilonewton. Once you get RDV, you can find out RAV, that is the sum of the vertical reactions going upwards will be equal to sum of the vertical reaction acting from the downward, towards the downward direction. Therefore, RAV plus RDV will be equal to 5 into 2 plus 10 plus 2 into 2, 5 into 2 plus 10 plus 2 into 2, 10 plus 10, 20 plus 2 into 2 is 4, which becomes 24 kilonewton. Therefore, RAV will be equal to 24 minus 10.2 kilonewton, which will be equal to 13.8 kilonewton at this point. Now, once we get this, now we go for the shear force diagram. When you are considering the shear force diagram, SF at A will be equal to plus 13.8 kilonewton. So here, SF at D is considered first. SF at D will be equal to minus 10.2 kilonewton. Then SF at C will be equal to minus 10.2 plus 2.2 into 2, which is acting downwards. We are coming from this end. So therefore, minus 10.2 plus 2 into 2 will be equal to minus 6.2. Between C and E, it remains constant, which will be equal to minus 6.2. Again, at the point E, minus 6.2 plus 10 will be equal to plus 3.8. Then again, between E and B, it remains constant at plus 3.8 kilonewton, and SF at A will be equal to plus 3.8 plus 5 into 2, which will be equal to 13.8 kilonewton. So this is how you will be able to get the shear force. Now we go for the bending moment diagram. Bending moment at the point A will be equal to 0. Bending moment at the point B will be equal to plus 13.8 plus 2, because as it is acting upwards, it will going to sag. Therefore, it will going to be sagging bending moment will going to be positive. Once you have the sagging bending moment is positive, then bending moment at the point B will be equal to plus 13.8 into 2, then minus 5 into 2 into 2 by 2. So that will be equal to 17.6 kilonewton meter. Then we have the bending moment at the point E. Bending moment at the point E will be equal to 13.8 in plus 13.8 into 2.5 minus 5 into 2 into 2 by 2 plus 0.5, 2 by 2 plus 0.5. So that will be equal to 19.5 kilonewton meter. So BM at C will be equal to 13.8 into 3, 13.8 into 3 minus 5 into 2 into 2 by 2 plus 3, 2 by 2 plus bending moment at the point C, 13.8 into 3 that is 5 minus 2 is 3, then minus 5 into 2 by 2 plus 1 minus 10 into 10 into 0.5, because here from here to here it is 2.5, and from 5 minus 2 from A to C will be 3. 3 minus 2.5 will be equal to 0.5. So it's summing up. So you are going to have 13.8 plus 13.8 into 3 minus 5 into 2 by 2 plus 1 minus 10 into 0.5 will be equal to plus 16.4 kilonewton meter. Similarly, bending moment at the point D will be equal to, here again we have 13 plus 13.8 into 5 minus 5 into 2 by 2 plus 3 minus 10 into 2.5 minus 2 into 2 by 2. So summing up, the calculation will be equal to 0. So this is how you will be able to get the bending moment diagram. So when you try to analyze how the plotting will going to take place, shear force at the point D will be equal to minus 10.2. Then because of the point load, then SF at C will be equal to 6 minus 6.2 kilonewton. That is because it is of UDL, it varies from minus 10.2 to minus 6.2, and it varies linearly because of UDL. Between C and E, it remains constant at 6.2. At the point E, because of the 10 kilonewton acting downwards from the top, so the shear force diagram will going to rises from minus 6.2 to 3.8 kilonewton, because due to the point load which is acting downwards at the point E of 10 kilonewton. Between E and B, it remains constant at 3.8 kilonewton, and from E to A, it increases from 3.8 kilonewton to 13.8 kilonewton linearly because of uniformly distributed load. Similarly, this is how the shear force diagram will going to work. Now, when you are coming for the bending moment diagram, bending moment at the point A is 0. Then bending moment at the point B is 17.6 kilonewton meter. So bending moment at the point B, it will going to join from 0 to 17.6 kilonewton meter parabolically, because the power of x in this case in the UDL is W into x by 2. So that means it will be Wx square by 2. So 5 into 2 by 2 becomes 5 into 2 is in meters. So 2 by 2 is also in meters. It becomes meter square. So therefore, the curve joining between 0 to 17.6 kilonewton meter will be having a parabolic curve. Similarly, the bending moment at the point E will be equal to 19.5 kilonewton meter, which will going to be a straight line. Similarly, between E and C, bending moment at the point C, as there is the no load at this point, so it will going to be plus 16.4 kilonewton meter. Again, it is a straight line. Similarly, between C and D, the bending moment ranges drops down from 16.4 to 0. Therefore, the curve joining between these two will going to have a parabolic curve because of uniformly distributed load. So this is how you will be able to analyze and solve this particular problem. Thank you.